Hello class, so this is going to be the intro video for the earthquake lab that we're going to have to cover together online. So again, how you get to this video particularly, hopefully you already got to it, but to this video and the rest of the material that you're going to have to complete for this lab is through the shell course, or course shell. So it's going to be 20 spring Geology 101 lab, and then that's physical geology lab. So once you're going to go to topic modules spring 20. So mine looks a little bit different from yours, but overall it's the same idea. Once you're there, you're going to go to earthquakes, which is chapter 9. And once you see that, there's going to be a few points that you're going to need. So the instructions for completing the earthquake lab, that's going to include this video over here. And it also includes this spreadsheet that you're going to need to complete the lab, and I'll take you through that later on. Below the instructions, or in your case, it's going to be like another link over here to the left, you're going to have the earthquake lab quiz, and then you're going to have the earthquake lab discussion board. So both of these are the ways through which you're going to submit your lab to me. Most of the questions are going to be in the earthquake lab quiz, but some of them, ones that I cannot really have multiple choice questions for, or even short answer questions for, those are going to be as the discussion board. Okay, so you're going to hopefully draw on that map that was attached towards the end of lab of the chapter, and you're going to scan it or take a really good picture of that drawing and upload it to this discussion board so I see how you did what you did for those questions. Okay? And then below those, as always, you have my lecture links. Those are always also on the lecture part of the course, or on that shell, so you have them in two different places. Okay? So that's how this part looks on Blackboard. I'm going to refer back to it once we go through the quiz and the discussion board. But for now, let's go ahead and cover what you need to do for this lab. Okay, so your lab is going to be starting on page 70, I believe. Yep, 71 of your lab manual. You are not going to start it until page 76 though, okay? So you're going to skip all of the first part. So all of this, what I'm going to scroll through, you're not going to do. And the reason you're not doing it is because you need a model that we have in lab, in the physical lab. So you won't do it. Okay, so you're going to start here, which is page 76. Part 2 and part 3 you're going to complete on your own. So I'm going to go through how you do it. So the first part, or the second part I should say, is going to be analysis of seismic data, and here you have the analysis of a specific earthquake. This is a real earthquake that happened in New Guinea. So let's read together. The seismic waves produced by an earthquake that occurred near Kepa, New Guinea have been recorded at many individual observation stations in that part of the world, so towards the east part. Your team thinks that this is a great opportunity to study how seismic waves travel. So you collect data from 12 different seismic stations. Those are going to be found under figures 5A and 5B, which are on pages 79 and 80 of your lab manual. Okay? Using the arrival times of both P and S waves, you and your team will ultimately create a graph that relates the difference in arrival time to distance traveled. Okay? So I know most of you probably have not seen a seismogram. So let me show you how you can determine what a P wave versus an S wave arrival is. So the P waves are going to come first, right? They're primary waves. So they're going to be the first signal that you have. They're typically shorter amplitude, and they come first. Then there's a little bit of time where there are tiny waves, but not much is going on. And then the S waves arrive within that seismograph. As you can see, S waves have a larger amplitude, and they usually come later. How much later depends on the distance that this particular location is from the earthquake. And we'll get to that as we go through the lab. Okay, so instructions for analyzing the seismic data. Locate the seismic data. Again, that's on figures 5A and 5B, which are on 79 and 80, pages 79 and 80. And also locate the Excel spreadsheet that is supplied by your instructor. So again, remember that I posted that on Blackboard. That was that linked spreadsheet. I will also refer to it in a second. Okay, so while looking at the seismic data, determine how long in minutes following the earthquake the waves took to arrive at each location. So here he says, note, you will need to use minutes and decimal minutes rather than minutes and seconds. So I'll take you through how we should do that. So again, this is where you're going to find the spreadsheet, either this or this other one. And once you have both the spreadsheet with you and you're looking at figure 5A, so on page 79, I'm going to put it over here for you guys to see. You should have something like this. So again, the instructions tell us to locate the seismic data. Got it. It's right here. And the spreadsheet. Got it. So while looking at that seismic data, determine how long in minutes following the earthquake the waves took to arrive at each location. Okay, so the spreadsheet has a few things. It has a location where you're supposed to input data about the P wave arrival and the S wave arrival. It has the distance that you're supposed to also put information based on what Ander gave you. It has the different locations that you have on figures 5A and 5B. Here's my dog. So cute. Good girl. Okay. And then towards the right, it also has two graphs. It has the P and S wave arrival times. So that's going to be filled once you start inputting some information. And it has the P wave and S wave arrival times versus distance. So as you go along, you'll see that these two graphs are different. This one is going to record both waves next to one another, the arrival time for each of them. And this one is going to record the difference between them, so the difference in time between them, and is going to give you a corresponding distance with that difference in time. So we'll go through that as well. Okay, so what he wants us to do is determine how many minutes have gone through at the time of the P and S wave arrivals. So I'm going to go through two different locations as examples for you, and you'll do the rest on your own. So let's start with Darwin, Australia, which is the first one that is listed here on figure 5A. So Darwin, it says it's 1,500 kilometers from the epicenter. So under distance, that's what you mark. Cool, no need to put units. And then we're going to record the P and S wave arrival times. So again, P wave is going to be the smaller amplitude waves that happen first, that come first, arrive first. Hence why they're P, primary. So I already prepared this a little bit. Okay, so that's my P wave arrival time, and my S wave arrival time will be right there. Okay, so if you examine where they come, the P wave gets to that location about 3 minutes and 3.2 minutes, probably, right? So if this is 3, this is 3.5, and this is 4. The difference right here is about, about 3.2. So the P wave arrives at about 3.2 minutes. And then the S wave arrives pretty much at 6 minutes. Okay. So if you look at the graphs, there's already something going on. Okay? All right, so this is the only part you're supposed to fill out. Anything else, you leave alone. Okay? All right, so next let's go through the location Vladivostok in Russia. So Vladivostok is right here. So he lists that Vladivostok is about 5,320 kilometers from Papua New Guinea, which is where the earthquake happened. And now we have to locate or find out the times at which the P and S wave arrived. So P wave arrived